Coordinates. The 2D Cartesian coordinate system. If we look into the number line, it's a one-dimensional figure. The two-dimensional coordinate systems, what is it? It is like two lines, they meet at right angles to each other. In what way is it used? So, it is used to mark the position of any object in a two-dimensional space in terms of its x-axis and y-axis. The horizontal line is called the x-axis and the vertical line is the y-axis. The point of intersection of these two perpendicular lines is called the origin, the coordinates of which is 0, 0. So, for any point to be located, we use the coordinate of that point and locate it in the two-dimensional space. The distances that are upward and towards the right of the origin are considered positive, and those that are downward and towards the left are considered negative. This we can very well understand from the use of a chart in the upcoming slides, where the entire 2D system is divided into 4 quadrants, quadrant 1, 2, 3 and 4. So, the quadrant 1 is the one which is mentioned here as upward and towards the right of the origin. So, all the points are considered to be positive, and those that are downward and towards the left, this will happen to be in the third quadrant, they are considered to be negative. What is a coordinate system? It is nothing but a mathematical framework that uses one or more numbers, that is the coordinates, to uniquely define the position of points or objects in the space 2-dimensional, 3-dimensional or on a sphere relative to a fixed origin. Now let's look into the key features of a Cartesian coordinate system. There are two perpendicular lines as we have seen already, the x-axis which is otherwise called the abscissa and the y-axis which is otherwise called the ordinate. They define a 2D plane. A third perpendicular axis which is called the z-axis is also added in the case of a 3D space. Origin is 0, 0. It is a point where the axes intersect. It acts as a reference point. The coordinates. Every point in the two-dimensional space, whether it is in any one of the 4 quadrants, they are represented by x, y, where x is nothing but the horizontal distance from the origin and the y is the vertical distance. The quadrants we know already, it is divided into 4 regions or the 4 quadrants. They are numbered counterclockwise, where the signs with the signs plus and minus indicate the location. Plus indicates is in the first quadrant, minus second quadrant, minus in the third quadrant, and plus minus in the fourth. In the slide you can see the 4 quadrants, that is the quadrant 1, 2, 3 and 4, and how to locate the points. This figure shows Rayan's room with points O, A, B, C marking its corners, meaning these points O, A and B and C, they define the corners of Rayan's room. The x and y axis are marked in the figure. Point O is the origin. O is anyway the origin, it is 0, 0. Now the x and the y axis are along the walls of Rayan's room. As you can see, the x and the y axis are mentioned in the figure, and the x axis is one of the walls and y axis is yet another wall. So referring to this figure, answer the following questions. If D1R1 represents the door to Rayan's room, how far is the door from the left wall? That is the y axis of the room. How far is the door from the y axis? Now D1R1 is the door. How Rayan enters his own room is by the door D1R1. If you can locate from the figure, the coordinates of D1 are 8, 0. The door is 8 units from the y-axis. The door is 0 units apart from the x-axis. What are the coordinates of D1? The coordinates of D1 are 8, 0, as we can very well find from the given figure 1.3. Question number 3. If R1 is a point 11.5, 0, how wide is the door? Now, R1 is the farther point of the door and its coordinates are 11.5, 0, meaning it is 11.5 units from the x-axis and 0 units from the y-axis. Do you think this is a comfortable width for the room door? How do we find the width of the room door? We know the point D1, which is 8, 0, as well as R1 11.5, 0. Now the distance along the x-axis for these two x coordinates will give the width of the room. So we can find the width of the room as 11.5 minus 8, which is equal to 3.5 units. So a person on a wheelchair will be able to do it easily when the units are considered in feet. 3.5 feet is nominal width for a wheelchair to enter. Let's look into question number 4. If B1 with the coordinates 0, 1.5 and B2 0, 4 represent the ends of the bathroom door, is the bathroom door narrower or wider than the room door? Now, this bathroom door width can be, this is along the y-axis. Why do we say that? The x coordinate is 0, meaning the dimensions have not traversed along the x-axis. We have values only in the y coordinates of both the points, meaning the door is along the y-axis. Now the distance between these two y coordinates, that is 4 minus 1.5, which is 2.5, will be the width of the bathroom door. But what is the question? Is the bathroom door narrower or wider than the room door? From the previous question, we found that the width of the room door was 3.5. This bathroom door is 2.5 units. So this is obviously lesser than the width of the room door D1. For this sum, we need to mark the x and the y axis on a graph sheet. Place Rayan's rectangular study table with three of its feet at the points 8, 9, 11, 9 and 11, 7. What will be the fourth foot of the table be? Plot these points in the graph as mentioned with the coordinates as it is given for three of the feet of Rayan's table. Now the points would be x1, y1 as 8, 9, x2, y2 as 11, 9, x3, y3 as 11, 7. So the fourth leg will be 8, 7, which is obvious from the graph also. Is this a good spot for the table? Yes. What is the width of the table? The length. Can you make out the height of the table? We can infer y1 is equal to y2. The difference between the x coordinates of the 2 points will be x2 minus x1 is 11 minus 8, which is 3 units. So this 3 units is the distance along the x-axis. So this is obviously the length of the table. Now the width of the table can be gotten from the difference along the y coordinates of the table. So it is 9 minus 7, which is equal to 2 units. So we can consider the length to be 3 units and the width to be 2 units. With the given information, it is impossible to derive the height of the table as we are looking into 2D plane, that is a Cartesian plane, the coordinate plane or the xy plane. If the bathroom door has a hinge at B1 and opens into the bedroom, will it hit the wardrobe? Are there any changes you would suggest if the door is made wider? B1, the coordinates are 0, 1.5. B2 is 0, 4. Hence, the width of the door can be derived as 4 minus 1.5, which is 2.5 units. If Rayan keeps the door open, the same width along the x-axis should be considered. The wardrobe begins at 3 units along the x-axis. So, the bathroom door can never hit the wardrobe if the width is kept at 2.5 units, but if the door is made wider, either the hinge should be made to open into the bathroom or the wardrobe should still be moved further along the x-axis depending on the newer width. Now look at Rayan's rule. Question number 1. What are the coordinates of the four corners O, F, R and P of the bathroom? The coordinates we can very well find out from the figure. O is 0, F is 0.9, 0, 9, R is minus 6, 9 and P is minus 6, 0. Question number 2. What is the shape of the showering area SHWR in Rayan's bathroom? Write the coordinates of the four corners. The showering area indicated by SHWR is a trapezium as one set of the opposite sides are parallel. That is, WR is parallel to SH. The coordinates are S is minus 6, 6, H is minus 3, 6, W is minus 2, 9, R is minus 6, 9. Question number 3. Mark off a 3 by 3 feet by 2 feet square for the wash basin and a 2 feet by 3 feet space for the toilet. Write the coordinates of the corners of these spaces. The wash basin space coordinates would be minus 6, 0, minus 3, 0, minus 3, 2, minus 6, 2, depending on the length along the x-axis being 3 feet and along the y-axis being 2 feet. The toilet space coordinates similarly would be minus 6, 2, minus 4, 2, minus 4, 5, minus 6, 5. Other rooms in the house. Now, Rayan's room door leads from the dining room, which has a length 18 feet by 15 feet. So, the length of the dining room extends from the point P to the point A. This is along the length, and along the width is it extends to about 15 feet along the y-axis. So sketch the dining room and mark the coordinates of the corners. Very simple. This is 15 units along the y-axis, meaning it will extend from here till here. So the dimensions of the room will be minus 6, 0, minus 6, minus 15, 12, 0, and 12, minus 15. These should be the dimensions of the room or the coordinates of the four corners of the room. Now, the next question will be place a rectangular 5 feet by 3 feet dining table. We need to place a dining table exactly in the middle of the room. So, how do we go about? We know the dimensions, the length along the x-axis and the width along the y-axis. So, we need to find the exact midpoint of the dining room. Okay, so the length along the x-axis is 18 feet. So half of it is 9 feet. The width is along 15 units. So half of it is 7.5. The exact midpoint of the room will be this particular point. How do we, so this particular point is the midpoint over here. So the coordinates of the midpoint will be 3, minus 7.5. How do we calculate 3? It is 9 units from the left wall. This is the left wall. So the coordinate of this is minus 6, 0. So from here 9 units will reach to x coordinate 3. Similarly, we need to find the y coordinate. Half of it is 7.5, meaning it will reach till this point. This is the midpoint of the room. Now we are placing a dining table in the middle of the room. So the dimensions of the dining table is 5 feet by 3 feet. 5 feet by 2 is 2.5 feet on either side of the midpoint of this particular room, and 3 feet by 2 is 1.5 extending on either sides of the midpoint along the y-axis. This will constitute the width. The other would constitute the length of the table. So, 3 feet. So, based on this, we need to calculate 2.5 feet on either side of the x coordinate 3. So it will be 0.5 to 5.5 length, and 3 by 2 is 1.5 centimeters on either side of the y coordinates, which is minus 7.5. That is minus 6 to minus 9. So the coordinates of the table or the four legs of the table would be 0, 5, minus 6, 0, 5, 9, 5.5, minus 6, 5.5, minus 9. Dining room